Hi guys, so today we're going to look at some trig, reciprocal, and quotient identities. Now reciprocal means we flip it as in a fraction, 1/2 and 2/1, 2/3 and 3/2. Those are examples of reciprocals. There are three functions that are called the reciprocal functions. The first one would be cosecant. So cosecant theta is written CSC of theta, and that is the reciprocal of sine, which means cosecant theta is 1 over sine theta. And if cosecant is the reciprocal of sine, then sine is the reciprocal of cosecant theta. They go hand in hand. Secant is abbreviated SEC. Secant theta is the reciprocal of cosine theta. And that also means that cosine is the reciprocal of secant. And the last set would be cotangent and tangent. Cotangent, or COT, we don't say cot theta. It's cotangent of theta is 1 over the tangent of theta. And tangent theta is 1 over cotan theta. Okay? Now, we know that the tangent of theta is sine of theta divided by cosine theta. And if we put that together with the fact that we know that cotangent and tangent are reciprocals, if the tangent is sine over cosine, then the cotangent is the reciprocal of that, cosine theta over sine theta. Okay, so we can write cotangent in terms of sine and cosine as well. Now, let's use these identities and find some trig values. So if I know that the sine of theta is 40 over 41, and I'd like to find the cosecant of theta, I know that sine and cosecant are reciprocals, so all I need to do is take the reciprocal of that function, and it's 41 over 40 is the value of cosecant theta. Nice and simple. Just flip the value. So if the secant of u is negative 3 over 2, then the cosine of u, and remember, secant and cosine are reciprocals, then the cosine of u, we just flip that over to negative 2/3. And in number 3, if we know that the tangent of u is 1 and we want the cotangent, tangent and cotangent are reciprocals. So the reciprocal of 1, remember 1 is 1 over 1, so when we flip it, we still get 1 over 1. The reciprocal of 1 is just 1. It doesn't change. They happen to be the same. Now take a look at number 4. Here we're saying that secant of theta is undefined, and we want to know the value of cosine theta. What the heck is the reciprocal of undefined? Well, think about how you get a value that's undefined. That means you had some number divided by 0, because it doesn't exist anymore, and that happens when we divide by 0. So if we take the reciprocal of that, and I don't know what the number on top is, but if I take the reciprocal, now I have 0 divided by whatever that mystery number is. And no matter what that mystery number is, when I divide it into 0, I'm going to get 0. So if one of my trig functions is undefined, its reciprocal is 0. Okay, let's try simplifying. So here we have the sine of theta times the cotangent of theta. Now usually, not always, but usually the easiest way to simplify is to put everything in terms of sine and cosine. Trig functions get no simpler than sine and cosine, and the other 4 trig functions can all be written in terms of sine and cosine. So they're as simple as you get. So if we have sine theta times cotan theta, that means I keep my sine theta, but I know that the cotangent of theta is cosine over sine. So this becomes cosine theta over sine theta. And if you look at that, you can say, well, you know what, I should put that sine theta over 1, so I have a fraction times a fraction. And wait a minute, lo and behold, this sine theta will cancel out with that sine theta, and all I have left is the cosine of theta, and you have simplified. Let's look at the next one. The next one, we have tan squared of theta. Now we know from up top that the tangent of theta is sine theta over cosine theta. That means that the tangent squared is sine squared of theta over cosine squared of theta, all over. And secant, we know, is 1 over cosine theta, which means that secant squared theta is 1 over cosine squared of theta. Now there's two ways to go about simplifying from this point. And some of you will say, oh, I've got a fraction divided by a fraction. So I'm going to take the top fraction, sine squared theta, over cosine squared theta. And when I divide by a fraction, I change to multiplication, and I flip the second fraction. And then you're looking at that saying, oh, wait a minute, look, my cosine squared thetas cancel out. Now I've got sine squared theta over 1, and that's just sine squared theta. And you would be done. And that's perfect. Absolutely perfect. But it's not the only way to do that problem. And I just want to bring your attention to another method, because sometimes it's good to know more than one way. Go back to where we have this complex fraction. Another way to handle complex fractions is to look at the denominator of the top and the denominator of the bottom and look for a least common denominator. Well, they both happen to be the same denominator. So I'm going to multiply the top and the bottom by that least common denominator, cosine squared theta. Now, why am I allowed to do that? Because cosine squared theta over cosine squared theta is 1, so all I did is multiply the fraction by 1. But in the top, cosine squared theta will cancel with cosine squared theta, and in the bottom, cosine squared theta cancels with cosine squared theta, and guess what we have? The only thing left in the top is sine squared theta, and the only thing left in the bottom is 1. So we have the same exact answer, sine squared of theta. Do I care which method you used? Nope, not at all. Whichever one you prefer, okay? Whichever method you prefer. Now, the next section, not only am I asking you to simplify, I'm telling you I want the answers in terms of sine and cosine. Because sometimes you can simplify it even more and get it in terms of a cotangent or a tangent, but I want everything in terms of sine and cosine. I don't want you to go back. But that also means when we're simplifying, we're going to rewrite everything. We're going to start by writing everything in terms of sine and cosine. So cotangent of the angle, remember, is the cosine of the angle over the sine of the angle. And that's all over. Cosecant is the reciprocal of sine. So that's 1 over sine A. And now you have the choice again. You can either multiply top and bottom by the least common denominator, sine A, or you can say, okay, I'm going to keep my top fraction, and since I'm dividing by a fraction, I'm going to change to multiplication, and I'm going to flip the second fraction. Absolutely nothing wrong with this method. The sine A's cancel out. We're left with cosine A over 1, and we never leave divided by 1, because anything divided by 1 is that anything back again. So now we know this simplifies to cosine A. And again, remember, the other option we had for this, and I'm just going to show you because sometimes one method is easier than the other. If we have cosine A over sine A, all over 1 over sine A, the least common denominator here is sine A. So I'm going to multiply top and bottom by sine A. So all I did is multiply by 1. The sine A's cancel here, and I'm left with cosine A. The sine A's cancel here, and I'm left with 1. And now I have the answer, cosine A. Same answer. Okay, now the next problem. Secant theta minus cosecant theta all over secant theta. We're going to change everything into terms of sine and cosine. Secant is the reciprocal of cosine. Minus cosecant is the reciprocal of sine. All over secant is the reciprocal of cosine. Now this one, you can't take the top and multiply by the reciprocal at the bottom, unless you could do the subtraction in the top first. You would have to get a least common denominator and you would have to subtract those fractions. But if you're already going to find the least common denominator, which by the way, if I've got cosine, sine, and cosine, my least common denominator would be cosine theta, sine theta. You know what you do? Since I already have to find it, multiply each part by cosine theta, sine theta. So we're doing this method of simplifying, okay? Now when we do this, in the first fraction, the cosines are going to cancel, and we have 1 times sine theta. In the second fraction, the sine thetas are going to cancel, and we have cosine theta. All over. And in the bottom, the cosine thetas will cancel, and we're just left with sine theta. And you know what, guys? I'd be perfectly happy with this answer. Nothing wrong with that answer as far as I'm concerned. Perfect. But there are some people who will say, wait a minute, if I've got subtraction in the top of a fraction, it means I used to have subtraction of 2 fractions, right? And sine theta over sine theta is 1. This answer is equivalent. I would take either answer. They're both perfect. Doesn't matter to me which one you use, okay? I'm happy with the first one, and it's less work for you, okay? Last problem of the lesson, we want to factor. Factor the expression 4 tan squared theta plus 4 tan theta minus 3. And you guys are going, oh my gosh, I don't know how to factor like that. So, okay, let's back it up. Let's try a simpler problem. Suppose I asked you to factor 4x squared plus x minus 3. This you do know how to factor. You may not love it, but you do know how to do it. You multiply first times last. 4 times negative 3 is negative 12. Now we need 2 numbers that multiply to negative 12 and add to a positive 1. Well, what would that be? That would be a positive 4x and a negative 3x. So we're going to break up the middle term there into 4x minus 3x, and we're going to keep the 4x squared and the negative 3. Now we factor by grouping. The first 2 terms have a common 4x, and when we factor that out, we'd have an x plus 1. The next 2 terms have a common negative 3, and when I factor that out, I'd have an x plus 1. And you will probably notice that they have an x plus 1 in common, which also means we're left with a 4x minus 3. And now we factored. If you can do that, you can factor this problem here because it's exactly the same. All I did is turn the tangents into x's. So in reality, you could, since you've already factored it, this is going to be tan theta plus 1 times 4 tan theta minus 3. Just put the x's back to tangents. And this is what the answer is going to be. But you didn't have to turn it to x's. 4 times negative 3 is negative 12. What multiplies to negative 12 and adds to a positive 1? That would be a positive 4, but instead of x, tan theta, and a negative 3 tan theta. And don't forget the rest of the problem, 4 tan squared theta minus 3. Now we group it. The first 2 terms have a 4 tan theta in common, and if I take that out, I'll have a tan theta plus 1. The next 2 terms have a negative 3 in common, and when I take that out, I have a tan theta plus 1. Now when I look before and after the subtraction sign, I see a tan theta plus 1. And what else is left? Well, I've got a 4 tan theta here and a minus 3 here, and we got the same exact answer. Awesome job. Okay, guys, I'll see you soon. Bye.